Here's an example 2 for multiplying binomials, also known as double distributions. Let's say we had 5x plus 2y times 7x minus 3y. Something like this. We're going to start with our rightmost term, and notice that I did not cover up the sign there. I want to distribute this across. So positive 2 times 7 would be 14. And as I've been trying to tell you in these examples, we always want to have our variables in alphabetical order so that our labels are always written the same way. And so I'm going to call this an xy. And then I'll do the second part of my distribution. 2 times negative 3 would be negative 6. Common bases, y would become a y squared. And then I'm going to move on to this 5x. I need to shift over. 5 times 7 would be a 35. Common bases, xx would become x squared. And then 5 times negative 3 would be negative 15, x, y, alphabetical order. As I said in the first example, you always expect to have 3 terms on these things when it's said and done. I do need to add these up, so this would be a 35, x squared minus xy, because when you add and subtract, you create no new terms. All I'm doing is combining like labels. So 14 take away 15 was negative 1 xy, and you don't have to put the 1 there. Bring the negative 6y squared down, and I have a trinomial. 1, 2, 3 terms. Let's go ahead and move on to another example of this. That way you have plenty to look off of. Example 3. Maybe I'll say that I have 5a minus 2bc times 3a minus 7bc. So we're going to want to multiply this. Nothing ever changes. We're going to do it the exact same way every time. I'm going to cover up this first term, and I'm going to distribute. Negative 2 times 3 would be negative 6. And then because none of the variables are the same, I'll just write them in alphabetical order. I'll say A, B, C. I move to the second distribution. Negative 2 times negative 7 is positive 14. Now this time, these are the same term. So it's a b times a b, common bases, become a b squared. A c times a c becomes a c squared because of the common bases. I move to this 5a. I do need to shift over as I distribute. So 5 times 3 would become a 15. Common base, a would be a squared. As I move to the second part, 5 times negative 7 would be negative 35. And once again, because all the bases are different, I would call that an A, B, C. I list that out in alphabetical order. Put a plus in front, and I simply add this stuff up. As I add, this becomes 15A squared. Negative 6, negative 35 is negative 41. A, B, C. And the final term just comes down. Pretty much what I was expecting. When I multiply a binomial times a binomial, regardless of the number of variables, as long as they look the same on both sets, so I had an A and a BC, an A and a BC, I do expect to end up with 3 terms when it's all said and done.